Alright, so the next one is the power of a product rule. Actually, instead of power of product, just make the power rule. I'll do that one first. Okay, so it's just a power rule. Okay, so let's say, for example, instead of x to the third power, we have x squared to the third power. Okay, so remember, that to the third power is just whatever's inside the parentheses. So that's just x squared times x squared times x squared. Now, if we want to expand that a little bit more, this x squared is just x times x times this x squared, which is x times x, times this x squared, which is x times x. So this is x to the 1, 2, 3, 4, 5, 6th power. Okay. So works out for a smaller number, but what if you had x squared to the 30th power? Yes.
Just multiply the two.
Yep, you just multiply your exponents. Because here, you don't want to write out x squared 30 times and then break it down more and more and more. So you say x squared, or x to the 2 times 30, which is x to the 60th power. Okay. So that gives us our general rule. Okay, so if you have x to the m power, and that is raised to the nth power, then that's equal to x to the m times n. Right, so let's say, for example, if we wanted to simplify say 3 squared to the 4th power. And write as an exponent. So you don't have to worry about solving it. Okay. So using the power rule, three squared, and that entire thing raised to the 4th power is just 3 to the 2 times 4, which is 3 to the 8th power. Yes?
If it was negative, how would you know to leave it as a negative or positive?
Actually, the negative exponents we're going to do next class. Yep, but negative exponents kind of have a different set of rules. Yes?
Is there going to be a next class? Because nobody's.
good question.
Have they said anything to you?
Haven't said a thing.
Wayne
I
State
just
closed like 15 minutes ago.
I just heard that the governor was giving a 2 o'clock state of emergency, but
Didn't he do
they-
it last night?
It's like,
I know, I'm like, they always pick after you get up and get here to decide to close it, but. Yep, but don't know. Like I said, it may not be a next class, but
what's the state of emergency mean?
that it's a kind of a local health scare. So the governor's
For
kind of
just Macomb?
invoking kind of the whole state really,
Okay.
since we have it in there. Yes.
So it's not related to this, but like, I don't know if you know this or not, but for some reason, if a class gets canceled or something, what would happen to our credits?
What?
That's the hang up. I don't know if they just have the class canceled or if they make it up at the end of the semester. So it's
When they just convert
If,
it to online?
if something.
Maybe
that's
just go
and that's it. I don't know
online.
if they'll convert it to
Well, that's the hard
online.
thing too, like,
Yeah.
You probably don't have, like, you're not probably not ready for like online.
No, actually, I
Oh, you
teach
are?
this class online too, so
Everything else is good.
it's some online works for some and not others. Not everyone has internet at home, or
Right.
so it's kind of one of those slippery
The
slopes.
Ultra Music Festival got canceled. They're not refunding anyone their money.
Yeah, exactly. So that's why
They just moved it
it's
to October.
just have to see what they
But Ultra's
want to
not
do
refunding
before I
anybody their
can
money.
go from
They
there.
said you can come next year or the year after
So.
that. We'll pay for it. Or we'll give you your money.
All right. So we're going to look at now the power of a product rule, which is what we had the first time. Okay. It's just a little tweak on the power rule. Okay. Let's say if we have, let's say instead of a to the power of m, let's say we have a times b to the power of m. Then all you're going to do is distribute that exponent to both of those. So that's a to the power of m times b to the power of m. I don't really need the if there.
What are we doing? I didn't pay attention.
All right, so let's say, for example, if you wanted to simplify, let's say 3x to the fourth power. Okay. Now if we have 3x to the fourth power, using the power of a product rule, that's just 3 to the fourth power times x to the fourth power. Okay. We know that 3 to the fourth power is 3 times 3 times 3 times 3, which is 81. So we have 81. That x to the fourth power just stays x to the fourth power since we can't do much about it. Okay. So that would be your simplified answer.
You said because we don't know what X is, that's why. X
Yep, that's why it just kind of stays like that.
I thought it was considered just 1x if we didn't know what x was.
Oh, it is. It's either 1x or x to the first power. All of those would just be x. All right, so what if we wanted to simplify, let's say 7x y to the second power. Okay. It's the exact same thing whether it's a product of 2, 3, 4. The exact same steps. So 7x y to the second power, that's just going to be 7 to the second power times x to the second power times y to the second power. So if we had 7xyz, it would be 7 squared, x squared, y squared, and z squared. So it would still be the same thing.
And even though it's not there, those are all considered to be multiplied together, right?
Yep, multiply together.
Okay.
So you can put the dot there, but you don't
need to.
you don't really have to.
Okay.
Okay, so we know that 7 to the second power is just 7 times 7, which is 49. So we have 49, x to the second and y to the second kind of just stays like that. So x to the second, y to the second. Yes.
So say if like y on the inside
Mhm.
had a 2 exponent, would you then multiply the 2 from the outside so that you have 4y?
Yep, you would actually do. Yep, you would do that too. That's when you'd use the power rule and power of a product rule together. And we're actually going to do one of those examples. Oh. Leave this up for a second. Alright, so let's say if we wanted to simplify. Instead of 7xy squared, let's say if we make it 7x to the third, y to the fifth squared. Okay, so we get this, and we still distribute it to each one of those. So 7x to the third, y to the fifth squared, that's just going to equal 7 squared times x to the third power squared times y to the fifth power squared. Okay. So even if it's an exponent already there, you just kind of still distribute it. Okay, so this was the power of a product rule, but remember the power rule.
Is that why you put the x and the y in parentheses, is because you're using that extra rule?
Yep, exactly.
Okay.
Yep, because as soon as you distribute it, you kind of work yourself right to that extra rule. Okay, so if you remember, x to the power of m raised to the nth power is equal to x to the m times n. Okay, so that means your 7 squared, well, we can make that 49 if we want to. X to the third power raised to the second power is just x to the 3 times 2. And y to the fifth power, and that raised to the second power, is just y to the 5 times 2. Okay, which gives us 49 x to the 6th, y to the 10th power. And just kind of write that on the side. X to the third squared is x to the 3 times 2. And y to the 5th squared is y to the 5 times 2, which is y to the 10th. So just a little side note. All right. Any questions on this one? All right. Nope.
No matter what, when it's inside parentheses and it already has an exponent, you
Mhm.
always make sure that you distribute the exponent on the outside first and then do the whole.
Exactly.
Okay.
All right. Now, what if that was a negative in there?
Then we wait for my exponent.
All right, so let's say, for example, we wanted to simplify. Ooh. Let's say -4 xy squared z to the 3rd, and make that to the 3rd power. Excuse me. Now this one you can really do it 2 different ways, but I'll do it the way I normally do it, then I'll do the second way, and you can figure out which one you like best. So you have -4 x y squared z to the 3rd power. We're going to go ahead and distribute that outside exponent. So that means you have -4 to the 3rd power times x. There is no exponent there, so you can just make that x to the 3rd power. You don't need parentheses for that one. That y squared, you make that to the 3rd power. And z to the 3rd, you make that to the 3rd power. Okay. So we know that -4 to the 3rd power is just -4 times -4 times -4. Negative and negative is positive. That positive and negative is negative. So we'd end up with -64. Okay. So we have -64. X to the 3rd. So we can leave that the way it is. Y squared. I'll make a little side note. Y squared to the 3rd is y to the 2 times 3. So you have y to the 6th power. And our z to the 3rd power. Z to the 3rd power is z to the 3 times 3, which is z to the 9th power. Okay. So that would be your simplified answer there. All right. Any questions on that one? All right.
When writing the answer,
Mhm.
all parentheses go away. Or when writing the simplified version, if that's all you're asking for, and for a.
Yep, because that once you distribute that outside
It doesn't
exponent,
matter.
yep, all those parentheses
Okay.
just disappear. Okay. Now another way you could do it, which is a little bit longer, you'd end up with the same answer, but, or let's say if you have -4 x y squared z to the 3rd power, you could make that -1 times 4 times x y squared z to the 3rd power, which becomes -1 to the 3rd power times 4 to the 3rd power times x to the 3rd power times y squared.